Hello, everybody, and welcome to our part 2 of our webinar for API and microservices development. In the first part of those webinars, we discussed about APIs and microservices, and we also built our first API and the Swagger definition for a simple API for managing member achievements. So in this second part of the webinars, we will go a bit more advanced and we will discuss about input validation, security, deployment using Docker, and integration with CI and CD. We're going to use GitLab and Heroku for deploying our API. So let's go into the code and see what we did last time. So this is a code from the part 1. And as you can see, we split the code into controllers, helpers, models, and services. The tech stack we are using is Node.js and MongoDB for the database. We have created the models for each table here, and we have two basic models, one for the achievement and another one for the achievement types. Then we created those endpoints for managing the achievement types and the achievements for members. Now, before we start writing the code for the part 2, we're going to do some cleanup and create some helper methods that will help us later for managing errors and generally for the input validation. We will start by creating a new service for throwing different types of errors. So I'm going to create a new file named errors.js, and here I will start writing the code for the error class. Here I will create a new class that will basically extend the existing error object from JavaScript with some more data for HTTP errors. All right, so this is the basic definition of the error constructor. And now we're going to create some default error objects.
Hey Thomas, can you explain us as you're going through with all these things, like you're typing all these things, like
Yes, so basically this method returns a constructor for a new error, which is exactly the same with the JavaScript error object, but it also has the HTTP status code and also the message that caused the error.
okay,
It will all make sense when we use those constructors right here.
okay,
Because later, instead of, let me give you an example here. Let's say we try to find an object in the database, but it doesn't exist. Instead of doing throw new error, we can do throw new not found error and provide a message here, and it will automatically throw an error with the HTTP status code 404.
awesome.
So we don't have to do the same thing every time and provide the HTTP status code.
Got it.
All right, so now we have the error constructor. Let's go and create another helper class for logging the errors and for logging in general. I'm going to name it logger.js. And here I'm going to copy and paste some very basic code that we use in most of our projects. And I'm going to explain what everything here does. But before I do that, let me go and install all the new dependencies. So here we're building a custom logger using the Winston library. So instead of doing console log, we will use this custom logger. The reason for doing that is so we have more control over what gets printed into the console. So for example, if we're doing local development, we can set the log level to debug, so we can see everything, including stack traces, etc. But if we're on the production environment, we can only set the log level to error, so we only get back the error and not every single information. All right, so here we are importing all the modules that we are using in this custom class. and we're creating a custom logger using Winston. And we're also creating a custom method for logging the error, including the stack trace. And here we have a custom method for automatically wrapping a method to use the Joy library for input validation. What this method does is it takes all the methods from a service, and if the method has a schema defined, that will make sense later on as we define some schemas in the services. It tries to validate the input when we call that method using the Joy library, and it also parses and normalizes the values using Joy. For example, if we pass this, which is a string, the number 1 as a string, it automatically converts it into a number, so we can use it later in the code. So this is ready, and now we are going to create another class for defining custom middlewares. And here we only need to define one middleware, which will be the error handler. Don't worry too much about the code. I will explain everything in a bit. All right, so here I created a middleware that will be used in Express that basically captures the error that was thrown previously. And if it was from Joy, it just takes the details from that object and it parses everything into a string. So this is all based on the error format thrown from Joy. You don't really have to worry about that. It's a very generic code that we use the exact same structure in every project. So next we're going to introduce this middleware into our index.js file. So I'm going to import it here. And I will import it as the very last middleware. All right, now we have the API running at port 3000 and it's connected to the database. Let's go and test if it's working correctly. It seems to be working. To give you an example of how the errors work, I will simply go into the achievement type service. I will import the errors. And here I will just throw a test error. Now, if I go and call the same endpoint, you can see that I got back a 400 bar request response with the sample error message that I provided into the constructor. So here you can see how we use those constructors for throwing different types of errors. If I wanted, for example, to throw an unauthorized error, and I just change that to unauthorized, and then call the same endpoint, you can see that the status code is 401 unauthorized. So I hope it's clear now why we created this error constructor class. Let me close all these files. And now we're going to do some cleanup and we're going to move all these route definitions into a custom route file. And then we will create a method to automatically import all the routes and inject the middlewares. So now I'm going to change the format of how we define the endpoints here. And it will all make sense later once we introduce the security, where we have custom middlewares for each endpoint based on if it requires authentication or not. All right, so now that we have every route defined here in this format, I'm going to delete everything from here. And introduce a new way of importing automatically the routes. Let's make sure everything works as before. Perfect. So as you can see here, I have imported the routes object from here. And then for each object within this main object, I go through its route, and for each method, for each verb, sorry, I set the method for that endpoint in the app object that was created previously. You will understand the reason why I did that once we introduce the security. So now we have prepared the code and all helper methods. Let's go and create and introduce input validation. I'm going to close all these files, and I'm going to go into services. And I will import the custom logger that we created previously. And then at the end of each service, I will just call the auto-validate method from the logger. And as the parameter, I will pass the module exports. I will do the same for the other service. And now all services are ready to support input validation using Joy. To give you an example of how this works, I will go into this method that takes a parameter, and I will define a schema for that method. So here in the schema, we have to define each property that the method takes as a parameter. So now if I go and call this endpoint with invalid parameter, let me find the endpoint name. So this endpoint expects the member ID to be a number. So if I provide a number, it works just fine. But if I provide anything else other than a number, it throws a bad request error with the appropriate error message, which is coming from the Joy library, which says member ID must be a number. And if you go to the Joy library documentation, you can see that we can support quite many things, for example, a minimum or maximum values, etc. You can see the full documentation here. Now let's go into the services and create the schemas for all the methods. So as you can see here, this should be a string. So here we need to define it as a string and also make it required. Same way here, I'm just going to copy and paste the schema from the previous method, and it should be the same. So the achievement service is ready and it has input validation as expected. Let's go into the achievement type service and add input validation to all method that requires validation. This one doesn't take any parameters, so we don't have to provide any input validation. But here, this is expected to be an object. And it should have a name, which is a required string. Here, because we need to accept an ID, which is an object ID from MongoDB, we need to make sure that the ID that we take as an input matches the format of the MongoDB IDs. For this, we're going to use a custom library, which is the Joy Object ID. I'm going to install the dependency. And instead of defining it as a string, I will just define it as an object ID. And I think we should do the same thing right here. All right. Let's move on to the next method. All right, so now we have everything ready and all endpoints have input validation. Are there any questions related to input validation before I move on to the next topic?
We don't have any questions in the chat, so we can move forward.
All right, perfect. So the next topic is security. So before I introduce security into any endpoint, I'm going to open the helper, the file that has the helper methods here. I'm going to create a few helper methods that will help us to generate and validate JSON web tokens.
Thomas, we have a question for the input validation. Harish thinks Harish says Joy is deprecated. Deprecated. Do you think uh, what else we can use here, or any other library you have in your mind for the same?
I don't have any other library right now, but perhaps there are alternative. I'm not sure if it's deprecated or if it was just renamed, because I see here, for example, it says happy/joy instead of joy. So let me try.
Okay.
Perhaps it was the specific, yeah. So if you go here, it's not deprecated. It was published 3 months ago.
Oh, I think Harish just clarified, and I think I misinterpreted. He said Joy is deprecated, but happy / Joy is not. So all
Yeah,
good.
it's basically the same thing. I think they just renamed the library.
Awesome. Got it.
All right, so let's move on to security. So before I write any helper method, I'm going to install the dependencies that we are going to use. So for this, we are going to use the JSON Web Token library. And let's import the library. In this tutorial, we're not going to create any registration endpoints with actual users. So instead, we're just going to mock it and provide the user role here, and the JSON Web Token will just have an object that has the role. But in the real world, we need a new table, a new model definition for users, which will have a username and password, the roles, and every other property that a user may have. But for this example, we're just going to keep it simple. So this is the method that will generate us the JSON Web Token, and we need another one to validate the provided token.
Okay, Thomas, Harish had another doubt, and he was asking, is CO required here? Is co or CO?
Sorry, was that?
Uh, Harish is
Oh, you
asking.
mean about the CO dependency?
Yeah.
Yeah, so we use CO so we can use async and await with Express.js.
Okay.
We explained that in more details in part 1 of the webinars. So if you want to learn more about that, you can refer to the video on YouTube for part 1. So here I created a method to validate the token that takes 2 parameters. The first one is the token, and the second one is an array of strings, which will be the array of the allowed roles for that particular endpoint. So I'm wrapping everything into a try and catch because the JSON Web Token library may fail to decode the token, and perhaps it will throw some custom error. So in that case, we need to catch the error and throw an unauthorized error that says the action is not allowed for anonymous. So once we verify the token and we get back the decoded JavaScript object, this object will have the role that we passed in the previous method right here. So if the roles array is defined, and if when calling this method, we provided the roles for that endpoint, it checks if the role for the current logged in user is included within the roles array. If not, it throws a forbidden error that says you're not allowed to perform this operation. I'm going to split the screen here and keep the routes on the right side. And then I'm going to go into the index file here. So right here in the code that we wrote previously that automatically imports the routes, I'm going to add an if statement. And if the definition of the endpoint requires authentication, this is a custom property that we will use later. I will push a new middleware in the actions array that will be used later. All right, so here, if the definition requires authentication, which is going to be a Boolean property. So let's go here, for example. So let's say we need to add authentication into this endpoint. We just need to do requires auth equals true. And this will automatically add a new middleware that will call the validate token method and will try to validate the JWT from the authorization header. So I think now it makes sense why we did that. And we have this code that automatically imports all the routes. So instead of having to add this middleware into its endpoint that requires authentication, we just provide a property here and everything is done automatically. And in the case we need to specify the user roles that are allowed to perform the operation, we can just do it by this. So now if I go and try to call the same endpoint without any authentication, it should throw an unauthorized error. Let's see what happened here. All right, so I'm trying to call the same endpoint that requires authentication without providing any authorization header. And I'm getting back a 401 unauthorized status with the error message that we provided here. So now to see this in action, we're going to create an endpoint for logging in. Let's start by creating a controller. I will just copy and paste the same. All right, so I created a very simple endpoint that simply calls the generate token method, and it returns a JSON object with that token. So if I now take this JWT and I go back to the previous endpoint, I can just provide it as an authorization header. This is a beer JWT. So now, as you can see, the endpoint works as expected. Let me try and generate a new token for different user role. And replace the previous JWT. So now if I go back here and I define the allowed roles to only allow admin users, and then call the same endpoint with the user JWT. Let's see what's going on here. All right, so the issue is that we never provided the user role here. Okay, so now if I generate a token again, all right, so the issue is that we have a try and catch here. So when we throw the error here, it catches the error, and instead of the actual error, it throws an unauthorized. So I need to remove that try and catch. Now it should work. Yep. All right, so now we have everything in place to support access checks on each endpoint. We have the methods to generate the token, to validate the token, and it's that simple to add authentication into an endpoint. Are there any questions related to security?
Yes, Harish has a question he's asking.
Sorry, was that?
Yeah, Harish said yes, he has a question, and the question is how to make sure the session information for this user is saved. I will repeat the question. How to make sure the session information for this user is saved once he is logged in?
So this is we are handling the session in the front end and not the back end. So when the front-end application calls the login endpoint, it should take back the JWT and, for example, save it in the cookies or in the browser session. So that's something that's not handled by the backend. What we can do in the backend, if we go into the JSON Web Token package here, we can provide the expire scene property. So for example, if we want the JWT to be valid only for a few hours or a few days, we can provide that property and make sure that if the JWT is expired, we don't accept the token and instead we are throwing an error. But everything related to storing in, the token in the session is on the front-end side. Does that make sense?
I think yes, yeah, it does. Thanks, Thomas.
All right, perfect. So now that we have everything in place, let's go into the next topic, which is deployment using Docker. So Docker simplifies and accelerates our development workflow. And if we set up the configurations correctly, it's super simple to spin up a local development environment that matches the environment where we will deploy our final application in production. So to do that, I'm going to close every file here, and I'm going to create two files, one Docker file and a Docker Compose YAML file. The reason we are using Docker Compose is because we have two services. We have the API itself and the MongoDB. I'm going to start from the Docker file. And we are using a node image version 10. We're just going to add everything from the root project folder. So this is a very basic Docker file, which simply adds everything from the project, runs npmi, which is the command to install the dependencies, exposes the port 8080, and then simply starts the API using npm start. Now I'm going to go into Docker Compose file. And I'm going to define the services that we are using. All right, so now we have the definition for our services. We have the database, which is a Mongo. There's a typo here. There's a Mongo image, and we define the name of the database here. and we also expose the ports. The default port is 27017, so we are going to use the same and expose it as the same port on our host computer. And then we have the API service, which has two environment variables. One is for the MongoDB URI. There is also a typo here. As you can see here, I'm using localhost, but here in the Docker Compose configurations, I'm using the database, which is the name of the other service. Docker will automatically assign the IPs will replace the database with the IP of this service. So we don't have to worry about that. I'm also defining the port where the API will be running. And then I'm defining the build here, which will read from the Docker file. I'm also adding a dependency and a link to the database service, and then expose the ports. Now that we have the configurations here, I'm going to stop the services from running locally. And I will just run Docker Compose app. I'm assuming that it's assuming that the Docker daemon is already running. All right, so as you can see, it's running and it's connected to the database. It's running on port 8080. So if I go here and I will just replace the port, I'm able to call the endpoint just fine. So now everything runs on Docker. I'm going to stop the Docker services again. And we're going to go into the next topic, which is integration with CI and CD. For this, I'm going to use GitLab and Heroku. I will start by going into Heroku. I already have an account here, and I will create two very basic empty applications. The first one will be the staging one. And another one for production. And since we are using MongoDB, I'm going to add a resource here, which is the MongoDB from MLab. I will do the same for the another application for staging. And now we have the two applications on Heroku that we will use to deploy our application using GitLab. I already have my code into a repository, and now I need to create another file, which is the gitlab-ci.yaml file. For this, I'm going to copy and paste the code, and I will explain everything in a bit. But first, let's go and introduce linked checking. For this, I will use the standard library. And I will go into the package.json file and add one more script, which is the lint, and it will just run the standard library. All right, so now we are able to run npm run lint and do a lint test in our code. Let's go back into the GitLab CI file and see what's going on here. So we have three stages here. One is for the setup, which basically just runs npmi and it saves the artifacts from the node modules directory. The next stage is the lint stage, which runs npm run lint, just to make sure we don't have any lint errors in our code. And the final stage is the deploy. Here we have two different definitions of the same stage, one for staging and another one for productions. And we define for which branches we're going to launch which command. So here we have some variables that we need to define into Heroku. We have into GitLab. We have the Heroku API key. So from our repository, we are going to go into settings, CI/CD, and we are going to create some variables here. We're going to grab the API key from our Heroku account. And we also need to create two more variables, one for the Heroku app name for staging, which is going to be tc-webinar-staging. And another one for production. So now we have the configurations into GitLab, and we also have our GitLab CI file here. And we should be good to push the code into the repository, and it should automatically deploy on Heroku. All right, so now as you can see, if we go into the CI/CD tab from our repository, you can see that we have this pipeline running. And the first stage is the npm install. Then we have the npm run lint, and then the deploy production since we pushed into the master branch. I have created a merge request from master branch into develop. And as you can see here, we have the pipeline. So we can just click the merge when pipeline succeeds button here, and once this pipeline passes and everything works fine, it will automatically merge the merge request and start the pipeline for the staging deployment. I'm going to do that right now. So as you can see, it's not merged yet. It's waiting for the pipeline to succeed. And if we go here and watch the logs, once it goes into the deploy stage, we will be able to see the logs here. While we are waiting for the pipeline to succeed, are there any questions related to the CI/CD integration?
No questions, Thomas. Thanks.
All right, perfect. As you can see here, the app got deployed and it's starting. And since the pipeline succeed, the merge request was automatically merged. And now we can see the pipeline for the staging deployment. Now, if I go back into Postman and I replace localhost with the URL from the Heroku app, you can see that I can call the API from the Heroku app. So now we have an API that has support for security, input validation, and it's fully integrated with both Docker and CI/CD. And with every Git push, it automatically deploys the code into Heroku. Let's wait for the staging deployment to happen. So I did some cleanup in the code and I pushed the new commit into the develop branch. And as you can see, we have another pipeline waiting in the queue. So once this one succeeds, it will automatically start the new deployment. All right, so it got deployed into the staging environment. So I will just replace the URL here and it works perfectly fine. And now if I go back into the CI/CD tab, you can see that the next pipeline is automatically started. So this is the end of this tutorial. If you have any questions, please let us know or reach out into Topcoder forums. And also let us know if you have any other topics that you want us to discuss into the next part. Thank you everyone for watching.